Hi all. This video helps you to learn one of the important supervised learning algorithms, that is decision tree. It helps us to learn from the trees and how to construct decision tree and how to use the decision tree for constructing decision. Let's start. What is the main important motivating factor for going to this data structure tree is the computational cost of making the tree is very low, and also the cost of using it is in terms of data points. For example, if you are having n number of data points, the cost of using tree is order of log n. Okay. So we are choosing this tree as one of the important data structures which is helping you to develop decisions. So the main idea of this decision tree is we are going to break classification based on the choices about each features. And that means the decision tree is having set of normally a tree is having set of nodes, right? So here the nodes are going to be the features, and the one which is in the root of the tree is the one which is having the most informations. From that feature we are going to progress down till the leaves, where the leaves are nothing but we are having the labels of this classification. That means whenever you are taking a data set for supervised learning algorithm, a data set is having set of independent features and one dependent features or the outcome or the label. So that labels are present in the leaves. When you are starting from the root node, the root node is going to have the important feature. With the help of that feature's value, we are progressing downwards, and we will reach for each of these, when you are going down, for each of these nodes you will be having some feature, and that feature's value depends upon the values. You will progress down continuously and you will reach the leaf, where that leaf is going to have the classification label. Okay, so let's go into this. There are different types of algorithms, decision tree algorithms. All these constructions are purely based on top-down recursive divide and conquer manner, and at start all the training examples are present at the root node, and here the attributes, whatever the attributes or the features what you are going to take here is going to be categorical value, because categorical value will be having finite set of values, like for example 5 or 6, like that, right? So if you are taking categorical value, the number of branches from that node is also minimal. But if you are taking continuous value, the number of branches will be infinity. That's why in case if you are having continuous values, you have to make it a categorical value. Let us discuss this later. And as of now, we are taking all the attributes or categorical value, and based on that, next what we are doing is based on the features what you are taking in the root, we are going to partition the examples or the input data sets, because at the start node all the training examples are present, and those examples are partitioned recursively based on the selected attribute values, right? And when you are after constructing this tree, the test attributes will be given, and the test attributes are selected, and when you are constructing this tree, that attributes how you are choosing it for the first node or the root node and for all the levels means it is based on some of the metrics, that is entropy, information gain and all. We will discuss it now. Before that, there are different types of decision trees. One is ID3 C4.5, which is the revised version of ID3, and another one is for classification and regression tree. And let us discuss about review of that entropy first. What is entropy? That is, in this information theory, we are using this term to tell us the amount of uncertainty associated with a random variable. For example, if you have a discrete random variable y taking some distinct values from 1 to m, right? And then we are calculating this h of I as minus of sigma I equal to 1 to m pi log pi. Here, what this probability, this pi is nothing but the probability, and we are trying to choose out what is the number of times that y value is having, y is having the value yi. Like that we are going to take it. For example, it is helping if you are having y1 to 1m distinct value, for each of these value we are going to take the frequency, that means the occurrence of y1, that is going to be the probability I, and that log of pi will be taken, and that summation for all those values will be taken. The negative value is of that summation is going to be the entropy. Okay, and what we are interpreting and what is the interpretation of this entropy is, if you have high entropy, that means it is high in uncertainty, and if you are having very low entropy, means it is lower uncertainty. Okay, and this information entropy tells us the amount of impurity in a set of features. Okay, so when you are taking this, with the help of that entropy, we are going to go to the next level, that is information gain. So that is how much extra informations we could get from each of these values of that features, right? So that's what we are going to take it here. For example, in our decision tree, the best feature is to pick the one to classify on our labels, our examples, right? So it is helping you to decide whether the particular example is belonging to label 1 or label 2, right? So the best feature has to be chosen first, and that is going to be the deciding criteria to classify your sample. So that best feature, how will you tell that that is a best feature is? The best feature is the one which is having the most information. That means the one with the highest entropy will be taken. Okay, and the information gain is taken from that entropy. That means what we are taking here is we are calculating the entropy for the whole training data set, and we are going to take one particular feature and we are dividing that feature based on that values present in that feature, and again we are calculating entropy for each of those subsets and take the summation of it, and that will be subtracted from the entropy of the whole data set. So that difference is known as information gain. For example, if you are having set of examples S, right? F is a possible feature out of that set of all possible ones, and SF is the count of number of members of F that have the value F of feature, right? What does it mean is, if you have 5 distinct values, each one will be taken, the probability of that in the total number of samples will be taken, and their entropy is calculated. Similarly, for each of these subsets, we have to calculate it and take the summation of it and subtract it from the total entropy of the data set. Once if we see the example, we can understand it very clearly. Let us take this sample S is having, this is a data set which is having 4 samples, right? S1 is having the label true, S2 is having the label false, S3 is having the false, and S4 is also having the label value false. This true false tells us the outcome label, right? And you may have set of independent features. One of that feature is F, which is having 3 distinct value, F1, F2, F3, right? Now we are going to find what is the feature value for each of these samples. For S1, its feature value is F2, and S2 it is F2, S3 it is F3, and S4 it is F1. Okay. Now, when you are calculating entropy of the total S, right? Entropy of S means for the total data sets you have to calculate. When you are calculating entropy for the total data sets, we have to see the outcome label. So, how many labels we are having? 2 distinct values, true or false is there, right? And out of that 4, how many are having true value? How many false labels samples are there? So, 1 true label sample is there and 3 false label sample is there. So, 1 minus 1 by 4 log 2 of 1 by 4 minus 3 by 4 log 2 of 3 by 4. That summation will be taken, that is 0.811. Right. So, this is the entropy for the whole data set. Now, we are going to take the entropy when you are using this feature value. What we are taking here is, for each of these features which is present in this feature value, right? So, we are going to divide these samples into subset based on the feature value, right? And out of these 4 samples, how many F1 value features are there? We are having only 1, right? So, this is 1 by 4, right? So, we are having first one, SF1 is 1 by 4 into, and out of this 1, how many 1 values are there? F1 is minus 0 by 1 log 2 of 1 minus 1 by 1 log 2 of 1. Okay. And second one, we have to take it. That means what we are telling here is, when you are taking that sample, the sample here is S4 and its label is false. That means it is true, it is having negative label and there is no positive label. As we don't have positive label, its value is 0 here. As it is having negative label false, its value is 1. Okay. Next, let us take this second feature. The second feature is F2, right? Second feature value is F2. Let us see how many samples are having F2. 2 samples are having F2, right? So we are taking out of 4 samples, 2 are having the feature value F2, right? And out of these 2, how many positive samples, how many negative samples are there? If S1 and S2, right? These 2 are here. This is a positive sample and this is negative sample. So, one positive sample and one negative sample is there. So, 1 by 2 log 2 of 1 by 2 and minus 1 by 2 log 2 of 1 by 2. Hope you can understand. What we are doing here is, out of the 4 samples, we are finding the subset of it based on the feature values. For the first subset F1, it is having single sample S4. For the second sample F2, we are having 2 samples. Let us take the third one F3. It is having only 1 sample S3. And we are seeing the labels present there. That label is mentioned here in this one. That is, we are trying to find out the probability of true values and positive, negative values, true and false values in that subset. So, for the first subset, we are having only one value and its label is false. For the second subset, we are having 2 values and one is false and one is true. And the third one is SF3. It is present in, that is, it is having the subset S3. It is having only one value and its label is also false. So, it is not having true samples. So, this is 0 in this case. So, 1 by 4 into 0 minus of 0 1 by 1 log 2 of 0 by 1. Okay. Now, we have to take the summation of it. So, when you are taking the summation of it with respect to the feature F, its value is 0.311. When you are calculating information gain, the information gain is nothing but the information gain with respect to feature F is minus 0.811 minus of 0.311. So, the final answer will be 0.5. So, this is the information gain for this feature F. Okay. So, likewise, you have to calculate. Let us go for the construction of tree now. This construction, when you are constructing this, first you have to compute information gain for each of these features. Out of all the features information gain, we have to choose the feature which is having the maximum information gain. Okay. And then that is, we are taking this possible trees in a greedy way only. And that means we are trying to choose which one is highest information gain with that particular subset. Initially, we are having all the samples with that. With the help of that samples value, we are going to calculate the information gain. And this output of this algorithm is a list of nodes, edges, and the leaves, which is constructed recursively. At each stage, the best feature is selected, and that once if you decide that best features, that will be removed from the data set, and the algorithm will recursively work for the remaining features until you reach the final label point. This recursion stops when you are having all the features with the same labels, or sometimes there are no features left out. All the features have been already worked on, right? That means you can stop developing the tree. Okay, this is the total metrics what we are using here, parameters what we are using here. Let us take the select the attribute with the highest information gain. That is the main important key point here, right? So, for each of this, we have to calculate the probability. The probability is telling for the total data set, the probability is nothing but the probability of the class out of all the data sets present here. The class I belongs to the sample number of samples belonging to the class I divided by total number of the samples D. Okay, and expected information, that is entropy, is we are calculating as minus of pi log 2 of pi, and the information is we are calculating with respect to information of the total data sets and the information we got after selecting one particular feature and taking the summation of that entropy of each of the subsets of those values, and that is subtracted from the total data set information. So, the final is going to be your information gain.